What's up, guys? Here you can see someone post a question in the Quora app, and the question is about a times b equal 48 and a plus b is equal to what is a, what is b. Now here on the screen you can see the solution of the problem by one of the engineer in the group. Now I am a part of this group. As you can see, I am also an engineer. Now I attempt to solve this problem. Just by looking at it, I say, okay, it's a simple what if show that question. So I attempt to solve it before analyzing this question. Now, as you can see, what I'm about to do is using the rule of simultaneous equation, where you have a product and a linear equation. So what I do here, first I say if both equation is correct, or if both equation is true, then you will have a solution. And when I say a solution, you will have a direct solution. So what I do first is to find a, make a the subject of the formula for the equation of a plus b equal to. So here, when I make a the subject of the formula, I will replace a in the equation ab equal 48. So I will have open bracket 2 minus b multiplied by b equal 48. So I will expand the bracket by multiply b by both terms in the bracket, which will result in 2b minus b squared equal 48. So what I'm saying here is I'm gonna have to change and rearrange this into a quadratic equation so that it can be simpler to solve. Now please bear in mind that these two equations, they are inconclusive because of some mathematical misfortune I will explain later on in the video. So I rearrange the equation to give me b squared minus 2b plus 48 equals 0. So I further carry on, writing b square plus whatever that is. So the thing is, what I want to do is to find a two number which when you multiply gives you 48, but when you add it, it will give you minus 2, and those two numbers were positive 6 and minus 8, and that is the 2b term that I will replace the minus 2b with. Now further on in this mathematics, I am getting so crazy because as I go along, I figure out that this is not going according to the rule of mathematics, and I am so crazy because I am almost halfway there. So I carry on further to find b minus 8 equals 0, hence b will equal a positive 8 for the first option for b. Then I check b plus 6 equals 0, then b will equal a negative 6 in this case. So as you all may know, that a quadratic equation will yield two different values, and a positive and a negative value. So the thing is, now I am going to test these variables in the equation a plus b equal 2. So I will just insert the value of b in a equal 2 minus b to get a value for a for the corresponding b terms. So I go along and I still see that this is not working out, because you can't have a positive number multiplying by a negative number to give a positive product of 48. So I'm just going crazy, guys, but I still carry on because you know that we are a mathematician and we don't give up that easy, and we also do a lot of engineering on the side. So I further carry on to find the corresponding value of a for the value of b equal minus 6. And then I get this. Wham! A equal 8. So the two variables is fluctuating between a equal 8 and negative 6 and b equal 8 and negative 6. So what this is saying is that this is the problem, guys. You have a positive number in a plus b equal 2. So I further carry on and see what I can do. Even though I know that this is not the solution, I am trying to apply every rule in maths just to get it right. That's what I'm saying, guys. So I further carry on to get the test done by inserting the values of the variables a and b to see if it is true. So this is the test, guys. I'm just carrying out the test. So here I am going to insert the values that we get over on the first page. So first, I will insert the value of positive 6, positive 8, and this will give us a positive 48. Ha! Ha ha! Whoa, something is wrong there. It's not equal to it if you use a negative 6 times a positive 8. You cannot get 48. So here I try using positive 8 and positive 6. And I indeed get a positive 48. But no, it is so puzzling because if you use the positive 8 and the positive 6 in the equation a plus b equal 2, you will not get 2. You will get 10. 10 million wrong bang. That is just me talking crazy. You will not get 2 though, because the 8 and the 6 will add. That will not give you 2, guys. I will give you 14 if you can see. So what I try here, I use the variable equal to 6 and a negative 8. And here you see, guys, the answer is 2. However, if you were to use these two numbers in the first equation, AB equal 48, it will not give you a positive 48. It will yield a negative 48. So I'm just going crazy again. And I was trying my best to get this correct because I will be the first one in the group to get it correct. But the thing is, it's not about getting it correct though, guys. Because if the mathematical rule does not apply to both equations, you will never get a solution for the two variables. That's what I'm saying. That's what I'm trying to prove here. So there we go. If we use a negative 8 multiplied by a negative 6, we will get a positive 48. So this is the next step. I'm trying some other way. I'm trying the next test. So this is the next test, guys. I say a times b equal positive 48, right? And a plus b equal 2. So we know that the prime factors for 48 is 6 and 8. So we use the 6 times 8 equal 48. So that is correct, right? So let us use the same test in the second equation, a plus b equal 2. That is not working, guys, because the same number you used in the first equation have to be the same number in the second equation. You cannot manipulate the numbers to get a solution for each equation. That's not how it works, guys. So it is inconclusive. So something is not mathematically correct about this sentence. Now, if we were to get a negative 48 or change the sign of the b plus a, then we will probably get an indefinite solution. But no, we're not getting a definite solution, guys. We will probably get a definite solution if we change the sign. Or maybe if we turn the sign into a variable. That's crazy, guys. So a equals 6, b equal 8. That's what we're using now, guys. That's what we're running with, okay?